there. I am busy hanging out with a cat, and as promised, I do want to spend some time talking about visualizing data for research methods. So, as I talked about, good data pictures can really help you truly understand the distribution of your data. That includes factors such as scale, location, spread, and shape. So, for example, your book gives the example of the idea of, does taking notes with a laptop tend to work better, or does taking notes with your notebook and pen and paper tend to work better? And so what we can do is we can look at, for example, some fake data from our laptop group with the percent of correct transcription verbatim. And as you can see, at least from this particular distribution, most people are pulling between maybe 10 and 20% verbatim transcription. We have somebody who's really close to zero. They're probably not even taking notes with their laptop. They're probably hanging out on a website that they probably shouldn't be on during class, versus 35, which is pretty good. So the thing is that when you look at data, you have a lot of different options of how to display your data. So previously, I showed you a stacked dot plot. And as you can see here, the higher dots indicate certain frequencies. So if you counted up all of these dots, this would add up to about the N of 31 that we're looking for. But it also tells you that several people were below 10%, several were close to between 10 and 15, and another peak was right before 20%. So there are a lot of different ways to consider your data. So I already showed you that stacked dot plot. Right now you're looking at a dot plot, which is shown in figure A. This is a case where the closer things are clustered together, the more the data, the more at that particular point. If you're interested in frequencies, you might want to look at a stacked dot plot such as this one, which I think helps give a better idea with frequency. I think a dot plot does a much better job looking at the spread. You can also do a histogram. Now, one of the things that's often very difficult about histograms is that you have to specify ahead of time the number of bins. So certain data points are going to go into certain bins. So for example, here we've got a frequency between 15 and 18. Based on this particular bin, we've got about 6 people, as 7 people, as you can see here. So here's 15, here's the others. And so between 15 and 18, you can actually see that that corresponds with 6. So here we have about 9 different bins: 0 to 3, 3 to 6, 6 to 9, 9 to 12, 12 to 15, 15 to 18, 18 to 21, 21 to 24, 24 to 27, 27 to 30, 30 to 33, 30 to 33 to 36, and then 36 and up. Trying to figure out bins, though, can be hard because look at how much our data changes if I increase the bins. So I think I have these messed up actually. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These should be reversed. Um, ah, this should be our 9-bin histogram. This should actually be our 12-bin histogram. So if you don't, oh, well, that's not really going to work. So in this particular case, our 12-bin histogram shows us one picture of the data. Our 9-bin histogram really modifies that data. So for example, if we're looking at our 12-bin, this almost looks like we've got some local high areas. This looks like it could almost be bimodal. In this particular instance, this looks considerably less bimodal. So figuring out the number of bins that you want can be kind of tricky. So make sure you specify. Now, one of the things that's nice about visualizing your data is that you can see some pretty interesting patterns. So for example, let's say that this is our laptop group, and this, for example, is our pen and paper group, and we're looking at percent transcription. So one of the first things that you can see with your data is location. Where is most of our data? Now, as you can see in this first panel, most of the data is in between like the upper 20s through the upper 30s. So most of our data is centered around our 30s. Now, on the other hand, if we look at our B data, most of this is between 60 and 70. And at least for me, this kind of tells me that one of these methods is probably more effective than the other for transcription. And one of the ways that we quantify where the majority of the data is by using a mean, a median, and a mode. Now, another thing that we can do is we can look at the spread of the data. Now, when you look at the data in figure A, you'll see that there's not that much of a spread. Really, scores are kind of spread from as low as maybe about 23 to maybe about 39. That's about 10 to 15 points from around 25 to 40. On the other hand, you can see that the spread for B is a lot larger. We're talking about over 30 points here. And we can talk about spread of our data in different ways as well. We can use things like standard deviation, we can use things like variance, we can use a range, as well as an interquartile range to quantify that spread. Now, when you're doing this, think very carefully about your measurement scale. Compare your theoretical range to your actual range. So here's what I mean by that. Your theoretical range is the range of what's possible for the measure. So on a scale of 1 to 10, actually showing 1 through 10 or 0 to 100. Now in this particular case, your theoretical range is 0 to 100, but it may not necessarily make sense to show that if people are not getting 0 or 100 in this particular case. We have our theoretical range. Our actual range itself is the minimum and the maximum scores that's actually obtained. So if I took the largest score from A and the smallest score from B, or from the bottom here, and I took the largest score from B and the smallest score for B, odds are pretty good that I'm going to find that the spread and the range for B is much, much bigger than A. Now, when interpreting data pictures, and sometimes this is really tricky because sometimes people like to cut off their axes, show the entire theoretical range if you can. That is not being done here, but you should do that. I've seen really bad graphs where people cut off the theoretical range to make the data look more powerful or more important than it actually is. So show the entire range of values that are possible. Additionally, and I think this is really important too, you'll notice here that even though I'm not showing the entire theoretical range, I do show from 20 to 80 for A and 20 to 80 for B. Make your scales the same for measures that you're interested in comparing. If your axes are different, if your ranges or scales are different, you're making an unfair comparison. And again, you're trying to make your data sound more impressive than it might actually be. Most graph software will often zoom in just to show the range. So if you're messing around in Excel, sometimes it's going to auto-fit based on the range. Do your best to try to include the entire theoretical range. If you don't know how to do that in Excel, I'm very happy to show you how. We've talked about location. We've talked about spread. Now we're going to talk about the shape of our data. And so shape is really the question, how many peaks are there? So here's some more fake data in C and D. And so as you can see here in figure C, we've got one clear peak. There are certain areas that have areas of height, like some potential local peaks, but overall, there is one peak that is greater than any by far. And this is what we would call unimodal. This is a unimodal distribution. There is only one peak. Now, in contrast, take a look at our distribution here. It has those two humps, kind of like I drew on the board earlier today. This is a bimodal distribution, and there are two peaks. Now, sometimes you'll have a data set or distribution that has two or more peaks, and we'll call that multimodal. There are multiple modes possible. Now, multiple modes will often indicate that there are distinct groups. So, for example, for height, People tend to cluster around certain heights, maybe one peak for women, one peak for men, and so on. Now, these are going to, when we talk about peaks, I know it's really tempting to think of this as being another mode here on another peak here, but we're ignoring those small little peaks and valleys. We are looking at overall global trends. And one of the things that you may find is that you need a lot of data to be able to judge the modality of a distribution. Now, we're going to talk about shape. So how symmetrical is this data? So what's kind of interesting is that both A and B are relatively symmetrical. So here's our peak. There's pretty much, for the most part, about as much data above the mode as there is below. Same true for B. But let's take a look at these. So if I look at E, for example, you can see that there is a very, very early peak around here. And there's a lot of data that goes far beyond the mode, above the mode, in fact. And this is what we would call a positive skew. We call it a positive skew because the tail sticks out further toward the positive side than the negative side. On the other hand, in the case of figure F, you can see here's our main peak. Most of our data actually falls below that. That would be a case of negative skew. Skew will often tend to happen due to aspects related to selections, such as minimum entrance requirements, minimum SAT scores, minimum GPAs, or things like that. Now, one of the things that you've seen is that really, yes, pictures are very helpful. And I mentioned that I really like a good graph because it helps me learn about the data. But oftentimes, I don't just want pictures, I want numbers as well. So like I said, we have location. We can look at mean, median, or mode. With spread, we can look at standard deviation, variance, range, or the interquartile range. Skew is often indicated by a metric called kurtosis. You can actually find a measure for kurtosis in Microsoft Excel, but we're not really going to talk about it very much. You should know what skew looks like, but I'm never going to teach you how to calculate a kurtosis measure. So now let's take some time to talk about using descriptive statistics to help describe your data. I'm going to go ahead and stop here so that we can start fresh with a brand new YouTube video. So give me just a second.